In this video, I'm going to take a look at RStudio and getting started with R code. Now, this is an interesting one because I don't actually use R. I have been using R to write the notes for this course, and I have used it many, many years ago in the past, but it's not actually my preferred package. So I've had to look up everything as we do it, and there's more than one way to do anything pretty much in R. So feel free to look commands up and do them a different way if you want to. Mostly I've been trying to do things the simplest way that gives us the output that we want rather than going for adding in too many packages. And then in the second part of this video, I will take a quick look at using R Notebook for those of you who are going to go on to do a lot more, I guess, actuarial science or data science, because I think this may be handy for you and it'll help you produce very nice output. But just in R, to get started, here we go. So the few windows that we need, we've got the console window and we can type things straight in here. So if you just type something into the console window, it will just run it. So you could put in one of these commands and run it here. Obviously, if you do that, you can't save anything that you've done, and often you do have to go to a lot of trouble to find the commands that you need in R. So you probably want to save them in a script file. So I will provide you this script file on Blackboard, but you can make a new one by just going New File, R Script, and you'll see there's lots of other things you can do here, and we'll take a look at the R Notebook in the second part of this video. So R Script file. If you have not done very much coding before, and this is not really full-on coding, you're not writing a whole program, it's just what I would call scripting. You're just putting a bunch of commands together. However, there's not a lot of syntax, so depending on whether you've done C# or Java or Python, the syntax may or may not be easy for you. You don't have to put semicolons and stuff at the end of each line. Equals is more of this arrow thing, because it's setting something, it's assigning something to a variable name, I guess is the way to look at that, as opposed to testing if two things are equal or some kind of Boolean operator. If we want to write something that doesn't run at all, we can do that with a hash. So a hash is a comment that doesn't run. So if I select these two lines of code and run it, it's printing out the line because it's there, but it's not actually doing anything. So once you've loaded in your data, you can, and you want to run it all, you can probably hash that out. I'm just going to leave it there. So this first line, it's not actually the first line, it's the second line of code, is to read in the data in Excel format because that's how I had it stored. However, that's not a native sort of format to import into R, and you need a package. This read Excel is the package, and you can tell it's a package because of the double colon. So if you don't already have this installed, you need to tell it to install this package and then you can use it. If you don't want to type the code, you can actually go to Tools, Install Packages, and just search for whatever you need. You can see there's loads of them. Read Excel. So that's the one. I've already done it. It will pretty much go through and install anything that it needs if you tick that box. So it's fairly simple, I hope. We say that in R and then things go horribly wrong. All right, so we can load in our apples data, and if you want to just take a look at the data, then I would honestly just open it up in Excel. I think there is a way to open it up into the viewer. Can't remember what that command is. We can just show the header information. So if I run that, we can see the first few lines. So this group was collecting apples, measuring their mass volume, calculating the density, recording the cost, and so on. So we've got a bunch of variables there. So if we were going to go through and summarize this data, let's say one variable at a time, then we would want to decide how we're going to treat each variable. Now, in this case, the categorical variables are fairly clear because they are, in fact, written with words, so there's no confusion. If you have categories coded as numbers, 1, 2, 3, 4, 5, then it may actually not be obvious that they're categories as opposed to numbers which have a meaning, so you might need to check with your data. I would usually start by doing graphs. Interestingly, R doesn't seem to be able to do a bar chart without first creating the table. So we kind of have to tell it to do a table of the variable we want, which is just variety in this case, and then it can do the bar chart, which it calls a bar plot. Not really any difference between a chart and a plot as far as I'm concerned. So if I run that, and this comes up in the plots window, and they had 48 of each variety because they had a nicely designed experiment where I think they each went and bought 3 apples of each type from different supermarkets and so on. So that's a bar chart. If we actually want the table, here what I've done is make the table and I've assigned it to the variable. So I've stored it in a table, in a variable. I don't have to do that. I could just do tables. I wonder if it'll run just the code selected or if it runs the whole line. Oh no, it'll just run the bit that's selected. So that's the type of thing where you should just be able to test it out in the console, and it should be able to do it assuming you've loaded the data in. However, I want to assign it to a variable name so that I can then create a table with the proportions. Now this is, to me, this is one of the real downsides of using R, because when you're getting started, you just want to do something really simple. You just want a table of counts and percentages, and it seems to be horrendously complicated. But R does have advantages if you go on to do lots of very fancy advanced things and you can customize your graphics and all of that sort of thing. So there's a big learning curve when you get started. So we can assign it to this variable name, and then we can print that variable, which we've already seen. But now that we've got it stored as a variable, we can tell it to calculate the proportions, which is probably no surprise that it's 25% for each variety, because we can kind of see that on the bar chart. Okay. I do have another command at the end to make a nice big table of everything, and I'll just show you something to watch out for that at the end. So that's categorical data. Not too much you have to do with that, I think, once you've decided it's in categories. Usually the difficult part is working out what your variables are if they're a little bit confusing. So let's move on to one of the continuous variables, and we have the density. There's some options in here, and I've written out what each of them do. The hist means make a histogram of this variable. Breaks is the number of bins. The main title, which you often won't need in a scientific article, you usually wouldn't have a title. You would have a figure legend which describes it. If you're tiling several graphs together, then you might have a title on each one. This is the font size for each of the bits of text. So the main one, the axis, and the labels. I can't remember what the CEX stands for, but someone can look that up and remind me. So if I run this code, so we've got the histogram with the 15 breaks, so that was the second command there. And if I go back one, I've got the histogram with eight breaks. So you can go back through your plots like this. Now, based on the histogram, we might choose that we want to summarize this with a median and interquartile range rather than with the mean and the standard deviation, simply because it is a bit skewed. It's quite common, depending on your area, that just everything is summarized with the mean and standard deviation. However, if it's not approximately normal, it can be a little bit misleading, and the median and the interquartile range might be preferred. But you'll have to check with your discipline about what they prefer. But normally I would look at the data first before deciding how to summarize it. If we wanted to do that as a box plot, again, the command itself is fairly simple, but there's a lot of options that you can type in. And you don't have to put these options in. You could just leave it at the default font size. And we get a box plot, which is handy for showing the outliers. Oops, accidentally dragged that. Now we might want to split that up by the variety because we may be expecting that the density is different between the 4 varieties. And that's where we get this extra little bit of code in here with the tilde, which gets used a lot in different ways. Here, what it means is split by, but you'll see it in other commands where it kind of means something a little bit different. So split by variety, and you could look up the commands to add some color into that if you wanted to. Looks like we've lost a name. Not sure what's happened there. I don't know if that got dropped because there wasn't enough room for it. Yep, there it is. That's handy. So you can resize it and the graph will resize, which is nice. No. We can do a scatter plot of 2 continuous variables together. So we'll look more at correlation and regression later in the course. I'm not sure there's much of a relationship here, to be fair. Looks like we have some low density apples. So this might be nice if we could color by the variety so that we could see if these were all one type of apple versus a different type. And then something that's surprisingly easy to do, given that other things are quite hard, is to do pairs of scatter plots if you want to have a look at a bunch together. So that's quite a nice graph. You can't really do too many of these at once. If you've got more than 3 variables and you want to do a matrix scatter plot, what can happen is that each of the individual plots gets so tiny that it's really difficult to see what's going on. So I'm not sure I like a matrix scatter plot as a general rule, but if you're quickly trying to look at a bunch of things in some data, it can be quite handy. So all of this, I think, should be part of the default R, except for the reading in the Excel. If you run these commands and get told you're missing a library package, that means I've somehow got something installed and didn't realize it. So it should tell you what you're missing and you can go to Tools and install it. The last thing that I've got here is this vtable. So you will need to install the package vtable and probably call on the library as well. So I think it can be installed in the background, but you actually have to load it into your session. And then you can get this summary table. And this shows up in the viewer. Now this is actually on the nicer side. It's not perfect. I don't think you could put this into a report without further editing. However, it does show us the counts and the percentages. It gives us the mean and the standard deviation for the cost. And you could look up some options to split it by different varieties if you wanted to, but just for this week, just being able to get some summary statistics out for one variable at a time is fine. So we've got the mean, the standard deviation. Interesting that it doesn't give us the median. So it's given us the 25th and the 75th percentiles, but not the 50th one, which is curious. So if you were going to use this, you might want to Google the options for this vtable and see if you can get it to put in the median in there. You wouldn't normally put all of these summary statistics in a report. You would choose which one you wanted, but while you were investigating your data, it might be handy to see them all. And then the only other thing that I'll just point out before we stop is at the end I've got variety coded. So this is where, for whatever reason, either I or the original group looking at this data decided that they needed to have this variety coded as numbers. And it's quite common that we code the data just for ease of handling. So let's assume they did it in order, but I don't have a code book, so that Golden Delicious is a 1, Granny Smith is a 2, etc. However, because it's been coded and it's now a numerical variable, R has treated it as a number, and it's put them all together and told us that the mean mean variety is 2.5, which is not particularly helpful. So there is a command that you can tell to treat a variable as a factor instead of as continuous. I'm not going to really go into that here, but just to point it out that if you see something odd, don't assume that the computer is right, because the computer could be wrong. It may just be doing what it thinks you want it to do, which is not necessarily something sensible. I didn't realize I was standing in the way there. I'll move that across. Okay, so that's a quick look at getting started in R for those of you who want to. If you come up with a better script or some easier commands to do the same thing, then please post it to the forum. In the second part of this video, I'm going to show you how to start a notebook in R, which may be more to your taste if you like things to be nicely formatted and you want to create your own set of notes similar to what I have on Blackboard for this course.